Okay, so in this problem we have three parts. We have a cone, we have a cylinder, and we have a sphere. So what we're going to do is we're going to find the volume of each of the three parts and add them together to get this shape, the volume of the solid, what they're calling the solid. Looks like a pencil to me, and that's kind of interesting because I use a pencil later on in Geometry B for a similar kind of a objective. But here we go. We're going to have, let's just talk about this here. We have to find the volume of this cylinder, or this cone, the volume of this cylinder. We know this is a three-dimensional object, so this is a circle base, and it's, r units tall. This would also be a circle base with a radius of r and r units tall, and this is a sphere with a radius of r. So we're gonna let me go to my pencil paper here, and I'll show you what I'm talking about. So I've got my cone on top, and I'm going to find its volume. And then I'm going to add in my cylinder, that's the part in the middle. And then I'm going to add in my sphere, which is the part on the bottom. And that really is a hemisphere, right? A hemisphere, which is a half sphere. So now you just have to know your formulas, and if you don't know them, you look them up, okay? It's pretty easy to Google them or whatever, but we should know at least these two because we, I've studied those a little bit. So a cone is, let's see, the area of the base, so the area of the base, which is pi, the base is a circle, so pi r squared, times the height. Well, in this case, the height is r. We were given that was r. And then we just divide that all in 3 because it's a cone. Now our cylinder is equal to the area of the base, which is pi r squared, times the height. And the cylinder was given to us that it had a height of r as well. Now our sphere is equal to pi r cubed. All right, and then what we do is we multiply that by 4 and divide by 3. That's our area for the sphere. The only thing is we have to divide that by 2 because it's a hemisphere. We're taking half of that. So this would be a full, that's the volume of a full sphere, and we're doing a hemisphere, a half sphere, so we have to divide that by 2. Well, that's kind of ugly. Let's rewrite it. Well, what's pi r squared times r? That's pi r cubed over 3 plus pi r cubed, all right, plus, now we have 4 pi r cubed over 3, 4 pi r cubed over 3 divided by 1/2, right, or divided by 2, and then what we do is we inverse and multiply, turn that into pi r cubed over 3 plus pi r cubed plus 4 pi r cubed over 3, and we turn that into times 1/2. So, what we can see here is that we have pi r cubed in common in all of these terms. So I would pull that to the side. Pi r cubed is to the side. And then what's left inside? I have 1/3 plus 1 plus 4/3 times a half. That's kind of easy to do. So here we go. What do we got? These guys are going to cancel. So I have 2/3. So I have 1/3 plus 1 plus 2/3. Okay. And that should be, these guys make 1 and 1 is 2. So 2 times pi r cubed. So my answer is 2 pi r cubed. Now to make sure of it, I'm going to put it in my calculator. I love my calculator because it does this kind of stuff for me. Okay, and let me just get it ready here. So let's test that out. So I'm just going to put all of this in here. I'm going to move this off the screen. I'll let you focus on my calculator for me for a minute. But I know that I'm just going to put it in exactly the way it looks on my paper here. Okay, well, let's try that again. I need to set that so it's not so blurry. Here we go. So the first term was a fraction. We had pi r squared. It was the value of the cone. So pi r squared times r over 3. Remember, we divide in 3 because it's a cone. It's not a full cylinder. And then we go Then we're going to add to it the volume of the cylinder, which was area of the base, pi r squared, times the height. In this case, the height was given as r. And now we're going to add to that the sphere, which was a fraction, and a fraction up top, which the area of the sphere was 4 pi r cubed over 3. But remember, we were going to divide that in half because we wanted to have, we wanted to take the hemisphere, so I wanted to do it in half. So now, hopefully that just gives me 2 pi r cubed, which is what I calculated by hand, and it did. I'm going to go back to Khan Academy in here and put in 2 pi r cubed. Okay. Do another one real quick. We want to take a pond in his backyard bigger. It's currently a cone, radius of 30, depth of 15. Wants to increase the radius to 40 and the depth to 20. How much more water will the pond hold? Okay, so I've got to calculate the volume of a cone with a radius of 30 and a depth of 15. Find that volume, and then find this volume with the radius of 40 and depth of 20. Subtract them to find the difference, because it's asking how much more. That means the difference. So let's go back to the paper here. I'll do this, actually try to get this right underneath there. Zoom back out a little bit. So we're going to take the volume of the new pool, and we're going to subtract the volume of the old pool. Okay? They both use the same formula because they're both cones. And so that would be pi r squared times the height divided by 3, okay, times pi r squared times the height over 3. The difference was that the radius and the height have different values. So the new pool, double check this, but I think it was 40 and 20. Yeah, 40 for the radius, 20 for the height. So we'll go back in here. So I go pi 40 squared times 20 over 3 minus pi, and the old one was radius of 30 and depth of 15. So here we go, pi 30 squared times 15 over 3. Okay, so I'm just going to save us all a little bit of time, just put it straight in my calculator. So I will have control divide. My first is a fraction, so control divide pi 40 squared times 20 over 3 minus control divide pi 30 squared times 15 over 3. Okay, and if I hit enter, I get that answer, which is 19,373.2 approximately. Now this has got pi in it, so I know it's not a rational number. So that's an approximate answer. I hit control divide for approximate answer. So let's go back here and see measured in cubic meters. They're not asking me for an approximate. They want a multiple of pi. So we have got to put in 18,500 pi over 3. So 18,500 pi over 3. Okay. See if it lets me put it in like that. There it is. Okay. Very nice from my calculator. Just gave me the exact answer. I could work that out, but I know that, it's just so much easier to do it by using the calculator. Okay, I'll have you guys work the rest of these out on your own. You can plug those numbers in and find this, okay? Good luck.